Hi folks, I have a very quick demonstration for you today. Recently I've been experimenting with getting analog input through the Raspberry Pi Pico 2's ADC into digital output and then analog output over I2S using CircuitPython. So what I have set up here is a little guy. It looks terrible, mess of wires. But what's going on is I have an I2S DAC, which is this PCM 5102A here. And then I'm taking analog input through a guitar with a guitar preamplifier, a very bad one, which you'll see later is why it sounds kind of terrible. It's just using an LM386. I'm not going to share the schematic. That's the mess of wires going on here. I'm not going to share the schematic because it's terrible. And then that's just going into GPIO 26 which is an ADC for the Pico 2. And this is my Pimeroni Pico 2 Plus here. And all that's running through CircuitPython, which I will share here in just a minute. Okay, here's our file. And I'm going to share these as GitHub gist later on in the description. And pretty much what we're doing is, we have a buffer size, a sample rate. Actually, the PCM 5102 can go a lot faster than 48 kilohertz. It can do like 384 kilohertz. And so can the analog buffio.bufferedin. But for now, I'm just using a pretty standard rate of 48 kilohertz. Anyway, we're creating our buffer. We're creating our buffered in thing, which will, pull in ADC samples into that buffer. And then here's where the magic happens. We're using the raw sample on Audio Core, this class here, and this acts as an audio source that we can work with. And that is just using our ADC buffer. And then we're making sure that single buffer is set to false. This makes it so we can continually update it. Otherwise, it'll kind of like save it in the background and never update it unless you create a new raw sample. And then we're using mixer here. It's not completely necessary, but I feel like it's probably going to help smooth things out just a little bit. And you'll notice here our sample signed is set to false. That's because by default, we're using unsigned 16-bit integer samples from our ADC, which I'll talk about in a little bit. And now here's where the fun part starts, is we're creating our effect here, which is the audiodelays.Echo, which should be in 9.2.0 as an experimental thing, but you can get it if you generate the firmware for yourself right now. Anyway, then we have some parameters. I'm just doing a half-second delay with a long decay so that you can hear it, and about 50% mix. We can play around with that, but I'm keeping that for now. Frequency shifting is for if you're doing modulation of that effect, that echo effect. It'll, instead of regenerating the buffer each time or whatever, it'll actually sweep through the buffer and create some interesting sounds. I'm leaving that off for now because it's not necessary for this example. And then we have some parameters here, and then we have our output, which is that I2S DAC. And then we're looping it all together. I have a quick demonstration of what's happening here. Pretty straightforward, actually. One important thing is to set loop to true. That'll make sure that it continually goes through the sample buffer. I haven't actually... No, that should work. That should work. It should be necessary. And now here's where the magic happens. With the buffered in, this ADC here object, we will need to read into that buffer that's connected with ADC sample and set loop to true. This means it'll actually run in the background, asynchronously, I guess. The only problem here is that it doesn't bump up the 12-bit samples to 16-bit samples. So you lose a lot of headroom. So as you'll notice, I have everything a little bit cranked on my end through my audio interface so that you can hear that properly. Okay, let's move on. And then we have our while loop. And in theory, you could do your control task here. So like, let's say you're changing the decay of the echo or the mix or whatever level. You could do so with potentiometers and stuff like that. Obviously, you have to be careful and make sure that there's some sleep time potentially, because it might get in the way of the ADC. And that's why you have to be really careful about your buffer size here. I actually have kind of a large one, which does create some latency. But I found that if I use something lower, like 1024 or 512, it still works, but you may hear some like glitching as the buffered in is loading into the buffer. Weird stuff like that. So I think it's better just to keep it a slightly higher value, but you will get some latency. Anyway, so then we do our little sleep here. I have these deinitialization, which actually I might need to update because I haven't updated for the effect in the mixer. This isn't necessary if you're just going to do while loop and never end the script. It's actually running right now, and I'm going to go ahead and grab my guitar so you can hear that. Yeah, here we go. There's going to be noise here. I apologize. It's because my preamp with the mess of wires is just really bad, so it's picking up a lot of noise, and it's not well designed. I might look into adding better preamps here or using a codec, maybe. We'll see. Here we go. Woo! You know what? I feel like the buffered I/O kind of gets out of sync after a while. Maybe that's something to look into. I'm going to restart this guy here first. Okay, let's try him again. Okay, it sounds better on my end. Here we go. Cool. I think I'll leave that for the demonstration. I didn't practice anything for y'all, so that's pretty cool here. Oh, I showed the wrong webcam, didn't I? That's okay. There's a lot of opportunity here. Probably room to improve both on the analog preamp side as well as in the actual, feeding the audio sources side to improve that even further. But I would say it's a good start. It's working, and that's fantastic. Anyway, y'all have a good one. And if you have any other questions, well, first of all, look at the GIST, but feel free to contact me on Discord, on the Adafruit Discord server. I'm D. Cooper Downpool on there. I'll have all that information down below. Y'all have a nice day. Bye.